Thank you very much. So my name is Nicolas Chuberre from Thales, working in 3GPP on the NTN Standardization, and I'm going to provide a small overview of the work that we have been doing as part of 5G, and also giving some perspective for 6G. So can you see my second slide? So this is now the part on 5G and 5G Advanced. And first, I would like to recall the ITR vision on the satellite component of IMT 2020. So there are three services that are being targeted by the satellite component. The first is EMBB-S. S stands for satellite because the characteristics of the service are somehow different from the terrestrial component. MMTC, so Massive Machine Type Communication, and HRC stands for High Reliable Communication. So as you see, it's different from the terrestrial component where you would have the ultra reliable low latency services, but in the case of satellite, the low latency has been dropped out for obvious reason of higher latency. You have a list of application scenarios that are listed, and of course we can see the transportation, public safety, connectivity to transport, and so on. And in response to that, 3GPP has defined two radio access technologies. So one, it's based on the narrowband IoT and EMTC with enhanced NTN features to support the MMTC-S, and the NR-NTN component to support the EMBB and HRC S services. If we can give an overview of a non-terrestrial network, it stands for the first and true global and open standard for all satellite communication systems, whatever devices, orbit, service, frequency bands, and beam size, and so on. We have distinguished three reference scenarios. One is depending on the terminal types that are targeted. So systems that would address IoT devices under 7 gigahertz, smartphones under 7 gigahertz as well, and other systems addressing flat panel antenna terminal on moving platforms, for instance, that would operate in above 10 gigahertz. The idea of NTN is to be to allow some integration with the terrestrial network component in order to combine both components for either ensuring service continuity or to reinforce reliability and availability. So you have a list of targeted use case. I've already touched upon that. And the idea is that this there is a common 5G technology framework to best manage the performance, QoS, security slicing across the access technologies, so the terrestrial and the non-terrestrial. So these are the targeted market segment, and so we distinguish between consumer market, and in there you can see the connectivity to smartphones or wearable devices, as well as cars, and you have some figures to give you the importance of the market. In terms of enterprise, is more specific, and for transportation, public safety, entertainment, and so on. So these are vertical markets. So I will not spend too much time on this. And here you have all the standardization activities that have been carried out to support NTN development. So one of the two technologies, access technology defined by 3GPP. And this started back in June in release 15. And as part of the release 15, there was the definition of use case for NTN, as well as the definition of channel model for the NTN. And then in the subsequent release, there was a study, and then normative phase started in release 17 with, I would say, the support of the NGSO and GSO, so non-geostationary satellite orbiting and geostationary satellite orbiting. So to be able to support the extended and variable Doppler and latency, and also to consider two different NGSO, the NGSO that generate Earth fixed beams, and NGSO that generate Earth moving beams. The target terminals in release 17 were the smartphones and frequency band S and L band. So it means 1.5 gigahertz as well, and 2 gigahertz. FDD mode was considered only. In release 18, we have extended with the norm with some additional feature to optimize the mobility between TN and NTN, but also to improve the uplink coverage, and to introduce a feature called verified location in order to increase the trust in the location that would be determined by the network. And one major feature was to extend the norm for systems operating in Ka band. Ka band stands for 20 and 30 gigahertz. In the release 19, this which is ongoing, a number of additional features have been added, and one of them is the definition of the Ku band, which opens up a new perspective for the NTN, but also some additional features, especially regenerative payload, the downlink coverage enhancement, because we had only the uplink coverage enhancement in release 18, and so on. And now in release 20, we are working on additional features like multi-orbit satellite networks that would combine GEO and non-GEO and so on. On the other access technology, the same has been done to support NGSO and GSO with extended and variable Doppler and latency. The same frequency bands were considered. The Power Class 3 user equipment were considered. And in release 18, some additional enhancements were defined. In the release 19, I would say a major enhancement was the introduction of store and forward capability, so that you could launch one satellite in low orbit, and it would collect the data from all over the Earth, and then convey this data to a specific gateway when he will fly above this gateway. So that's a way to reduce the number of satellites needed to provide a global coverage, but of course non-real time. So other enhancements are being considered, and in release 20 there will be IMS call over geo and enhanced emergency communications over IoT NTN, so to enrich the service capabilities of already launched system. Here is the timeline of the rollout of the technology defined by 3GPP. So the first is the deployment of narrowband IoT with NTN capabilities over geostationary orbit satellite that in order to address IoT devices. In 2015, there will be low orbiting satellite addressing IoT devices. They have already been launched, but the service will be open in 2025. Likely, there will be another launched in 2026, which is to serve IoT devices with a full constellation. And then you have in NR the broadband over geostationary satellite with transparent payload. Then likely around 2027, 2028, direct connectivity to smartphone based on the 3GPP NTN standard. And last, some broadband network using NGSO in operating in KUKA and with regenerative payload. So this is the overall roadmap. This is based on public material. For 6G, well, the 6G is expected to provide new capabilities to support new use case. There will be reinforced security, trustworthiness, sustainability, and resiliency. Resiliency is very important. Of course, the main contribution of NTN remain ubiquitous coverage, but resiliency also is going to be very important because NTN can provide a backup network. The interoperability across 5G and 6G will help to support the migration of our existing space segment. And we have seen the rollout of the space segment to support the 5G radio access technologies. And this space segment would be used to migrate also towards 6G. So before specific new space segment can be deployed specifically for 6G. So that's why it's very important to allow this interoperability. We expect the radio interface of 6G to be NTN friendly from day one. So it means that at least it should support this extended and variable Doppler and latency inherent to the satellite communication. In order to allow this joint operation between TN and NTN, because in 5G, both components were somehow decorrelated in terms of operation. And as part of 6G, there is an opportunity to allow a joint operation to meet some challenges, to better meet some challenges like seamless service continuity. In the preliminary list of use case for 6G with NTN, we see somehow some similar use case as 5G, but with enhanced performance, like direct connectivity. We expect to achieve better data rate and even coverage, going towards indoor, for instance. The high-speed broadband connectivity is being expected, so we expect to have a much higher data rate than with 5G, and there will be some the need to support strengthened regulatory requirements. So this might affect the system architecture and radio access network architecture, and also some complex connectivity scenarios to area and theater of operation, especially for disaster relief, will be enabled in 6G. Okay. These are the kind of features that are going to be introduced. Well, first, the support of very compact and self-tracking flat panel antenna for vehicle and UAVs mounted device. The GNSS-free operation means the capability of user equipment to operate without any GNSS receiver in order to increase the resiliency of the network. Seamless NTN service continuity currently in 5G is not seamless, and we'd like to go towards seamless. Reliable determination of UE location. Currently, the location is being verified, but there is an interest to have the network capable of providing the UE location by itself. The mesh connectivity means UE, satellite UE. I think also a better combination of NTN and TN over a specific area. I think we already discussed about that. Also, the possibility to combine NTN and TN for higher sustainability and resiliency, and multi-tenant non-terrestrial network infrastructure, spectrum coexistence between NTN and TN, as well as the introduction of integrated sensing over NTN. This is a multi-layer infrastructure, geo, non-geo, HAPS, and so on, that would address multi-terminal types and usage conditions. This will require a flexible radio access technology, and unification with terrestrial network component is going to be needed, and we expect to have more network functions on board the satellite. This is the timeline and of what we in 3GPP. It's going to start with a study phase, and then the normative phase would start in release 21, and the counterpart in ITUR at work party 5D. This is the expected timeline, and in ITUR work party 4B, this green sort of timeline is being discussed but not yet approved. But that would be what that would allow to have the NTN and TN being defined concurrently for a joint operation. I'd like to give you give you some reference. Here is a paper that was published by several companies involved in a European project. It's a vision on non-terrestrial networks in 6G. It provides use case requirements and possible standardization approach. So yeah, you can have it, and then you have some reference on some special issue in International Journal of Satellite Communication and Networking, as well as a book that was published earlier this year. So there was thank you very much for your attention. I hope that if you have any questions, I'm ready to answer. Thank you.